Okay, I ran a corrosion test. Here's some of the notes I took. It was on the 8th month, 21st day, 2012. I used 60 grams of distilled water added to both cups. 0.285 grams of alum was added to each cup. One cup gets vegetable oil on top. The cup with the water and the oil, the magnesium originally weighed 0.152 grams. The one with just water was 0.160 grams. Also, I want you to note that I did use distilled water. So that's very important. I didn't use tap water. It's actually distilled water you get from Walmart. I ran a test. Right here is the two cups right here. This obviously was the one with just distilled water, and this one was with distilled water and oil, vegetable oil on top. And I got some interesting things to report. From what I can see clearly is that alum and water corrodes magnesium. Well, just really corrodes it. It's a destructive corrosion. There's nothing good about this corrosion at all. It corroded the magnesium ribbon completely. Actually, you can see right there is a bit of the magnesium ribbon that I pulled out of the water. I was shaking and air drying it to get the water off of it, and it flung to the side. And if I hold this piece of magnesium up to the screen, you can see that there's holes in it. You can see there's holes in it. And this magnesium that was in this distilled water only, you can see the water's condition and what it did. It's like it did grow some some alum crystals in there because it was evaporating. They both had about the same amount of water in them, but this one obviously lost water because the alum was allowed to evaporate. You can see some of the holes in the magnesium right there too, in this magnesium. This magnesium originally started out at 0.160 grams. This is just the water one. And we're going to measure the weight of it now. We're going to tear the scale, put this on top. And you can see we're at about 0.136, 135. And we started out at 0.160. So we lost some weight. Obviously, you're going to lose weight when you have pieces in the middle fling off when you're drying it, air drying it. So I thought that was interesting to point out that alum and water is very corrosive. Now the oil on top actually did help a little bit, but it's still corroded. The corrosion is not as bad. I don't know if you guys can see it, but it does still have. You can see through it too. If I can dry it off, see if anything flings off. If I hold it up to the screen, you probably, well, it's kind of hard to see, but the edges of it are decomposing. So you can see the edges on it are decomposing. Separate it from the copper. And you can see the copper has a buildup of white alum on it. Dry it off a little bit. Try not to. You don't want no water in there to ruin your results. But you can see some of the edges of it are corroding away. And this one started out at 0.152 grams. So let's have a look at what it weighs now. We're going to tear the scale. We're at 0.147, 1.46. We started off at 0.152 grams. So as you can see, it is corroding. So the evidence is the proof is in the pudding, I guess you could say. Alum and water corrodes magnesium. There's no other way to put it. It just does, and even though it's growing alum crystals, it still corrodes. Yeah, and the alum and water and oil does slow down the corrosion, but the corrosion wasn't stopped. As you can see, that one too is still corroded. It corroded on the sides much more than anything else, which was very interesting, but it's still corroded. I did pick up a nice big piece of magnesium rod here, extruded rod. So we're going to have some fun with this bad boy, make some cells out of this. Got a test. I'm running a test just like I did with these alum water. I got right here. I'm using detergent and oil, and you can see it's black. We hold it up to the TV screen. Nothing shining through, so it's still one solid piece. As you can see, still one solid piece. Put it back in there. Still testing that out. This one's just like that one too. Detergent and oil on top. Still testing that one out. This one right here. This one's actually very interesting. This is tap water and vegetable oil. Well, look at the magnesium ribbon. There's only slight a bit of black. It's very thick black in those regions too, but there's still shiny parts of it. Hold it up to light, and it's not shining through, so it's still one solid piece. I think that's very interesting how that's working out. It's been going like this for about 2 weeks, and that's much corrosion it's going to give me, I guess. Maybe more. I don't know, but it's very interesting. And this life of this cell started out with tap water oil already there and mixed, and then I put shorted out the electrodes into the water and mixed. This one right here, it started out as just tap water. This one right here. It started out with tap water. Then you can see it starting black. You can see the water line right there where it changes color from gray to black. But yeah, then I added oil on top to stop the corrosion, and it seems like it's working. Well, this one right here, from the get-go of tap water actually, with the oil right on top, is showing very good promise. These two right here, the alum and water, are just not a good combination. They corrode, and the proof is in the pudding. They lost weight. They fell apart. That's destructive corrosion, and that's what I'm trying to avoid. I'm trying to mess with additive corrosion, which these cells are starting to show. There's a couple more. Yeah, that one's. That's what happens when you have vinegar. It actually eats the magnesium away, but it stops at a certain point. But that's not the point of this video. I just wanted to show you guys that alum and water is very corrosive to magnesium, so I would avoid it.